Hello, thank you for joining us on this training video that will specialize on the contour data module and advanced data map concepts. So let's get started. We're going to open up one of our sample applications, and it's in the projects, studio projects, and the drill guide folder. And it's this one here with the solid colored contours. This application is very simple, and it has the contour data module in it. You'll notice that we have a legend, and unlike most applications that you'll see, the legend has two connections to it. Sometimes we'll have a connection when we have lithology data. We'll use the yellow port for the geology legend, but few applications use this orange port. It's only available to you from the contour data and the isolines module. So those are the two modules that you would ever use that port with. Let's talk about contour data, how it works, and some of the special things about it, why you would want to use it. There's many things that it offers. It can be used on with any surface data. So that surface data can be the surface of a plume, the surface of a 3D model, but it applies only to analytical data. So you can't contour geologic data like material or geolayer, since it already has discrete intervals. It already is contoured, in effect, solid color banded, as this data is. Now, I want you to remember what the data looks like that comes into contour data. So from Creek 3D, we have continuum colors. And you'll notice that when I disconnected and connected, the screen size changed, the scale changed. And we're going to go in and fix that so it doesn't happen. Under Viewers Properties, right here, you'll see this Auto Fit Scene, and the default is On Significant Change. I'm going to switch that to be Never. And that means that when the extents of my model change in here, for whatever reason, it's not going to cause the screen to reset size and rescale. So I'm just going to do that one change real quick and give you another little feature that you saw there. Also, you'll notice in Creek 2D, we have this white dot, and that displays the highest uncertainty point. And if you want to know how to turn that off, it's under Display Settings right here, and now it's gone. So this, again, is the continuum colors that we use for most analytical data. Our legend doesn't reflect these continuum colors because we're still seeing the legend connected from contour data. And so this is what we're used to seeing with most modules that we use. Contour data instead gives us these colored bands. Now, there are many times when you may just want to see your data in colored bands because you prefer that visualization. But also, if you're going to export your results to software like ArcGIS or even AutoCAD, for either of those, it's almost always best to use contour data and isolines for the export, because neither of those software packages support the continuum gros shading that we're used to seeing. ArcGIS does not, because it only works with cell data. And cell data means that each cell is colored a constant color, a uniform color. So you can't have a gradation of colors within a cell. Now this model has a pretty fine grid. And if we wanted to look at, let's go back here again and look at the grid first in Creek 2D. So here's our Creek 2D model. And we would double click on the red port, either the output port here or the connection, to bring up the properties for it. And to see the grid, all we need to do is switch the line display mode to regular. And if we zoom in, we'll see that we have these nice uniform squarish cells, rectangular cells, and they're also adaptively gridded. So where we have sample data, we're going to see this type of refinement, and we're going to have sample points that will land on one of those on one of the nodes, corners of those refined cells. We can see where our data would be by adding the Post Samples module. I'm going to connect the file port and PostSamples will run. Now you'll see that PostSamples is 3D and we have a 2D analysis. But when I go to a top view, and we can zoom in again, that you'll see everywhere that we have this refinement is where we have these samples. But PostSamples lets us see our data collapse to 2D the same way that happens in Create 2D. So we can process, instead of processing 3D, we can collapse to 2D. And when we do that now, our samples end up right on all of our locations. And we'll see everywhere that we have a sphere, because we have adaptive gridding on in Create 2D, we have this refinement of the grid. All right, now what I really wanted to show you was how this grid compares in look to Contour Data's grid. So here's the Contour Data grid. You can see the sample points again. And if we go to the properties for it, double-clicking on this red connection, I go and switch the line display to regular. And now you'll notice that the regular array of rectangular cells is broken at the contour boundaries. So if we zoom in on contour boundaries, we're going to see that the cells intersected by the contour boundaries are further refined and such that there are unique cells lying within the contours. So there's this cell right here, let's zoom up on it even more. This was our original rectangular cell, but it is now broken so that part of this cell is solid yellow and part of this cell is solid green. And that required, these additional cells in here that we see. So this refinement happens automatically for you, and it happens in Contour Data. Okay, I'm going to switch off the cell outlines again. Now, so that when you export to CAD or shapefile, you'll have bands that are solid colored and have an attribute. And the attribute that goes for that band is going to be constant for the entire solid contour band. Now, we can appreciate and see just how that data assignment occurs by comparing the statistics output from Contour Data and from Create 2D. So we'll type S to get a statistics module, and I'm going to hook it up first to Create 2D. Now to see it better, I'm going to undock it, and I'm going to go to statistics, and I'm going to jump up the number of bins to be about 25. Don't need the window that big, so we'll put it right here. So let's put this over here for a second. Now, you can see we have 25 bins, and because we're dealing with continuum data coming out of Create 2D, it's continuum data, there's some number of points in every bin. You can see this has somewhat of a normal distribution. In other words, somewhere in the middle here, there's the bins that have the most. There's one bin from 0.08 to 0.17 that has 1,900 points in it. Our whole grid itself has 14,847 nodes. So not a lot of nodes compared to what we get with 3D grids, but still it's not trivial. And so we see this distribution of the data bands. Now when we switch to look at the statistics out of Contour Data, it's going to be a different story. Notice that not every band, not every histogram band has any counts. The very first one does, and it goes from 0.03 to 0.056. In order to see why that band is the way it is, I'm going to go back to Contour Data and show you that we've asked for the band data to be at the average of the band. So each band is defined by the min and the values at the bottom and the top of this band. And the average of that bin is the average in logarithmic space. So the average of 0.01 and 0.001 and 0.01 would be the log range that would be in the middle would be 0.03 roughly. So this is the lowest data we see in this grid is that band that's at 0.0032, and that's this entire darkest blue color. So these regions here, that circle and this end, are the regions that are at 0.0032, and that contributes to these 1,600 counts. Our next band is the average between 01 and 08. Here it's probably at, in this 0173 to 0306. Somewhere in there, we're finding that average band between 01 and 08, and there's 4,500 counts in there. You can see a larger area is light blue. Our next band is here between 0.29 and 0.52, and that would be the average of the 0.08 and 0.1, 0.3, so 0.5, somewhere in there is roughly 0.3 to 0.5 is where this average band occurs. So the histogram intervals are breaking the log data up into 25 bands, but you can see that there's only 7 discrete bands at which data occurs. 1, 2, 3, 4, 5, 6, 7. Because we have 7 bands in our contour data. 1, 2, 3, 4, 5, 6, 7. Okay, so there I mentioned this band data parameter. I didn't actually mean to dock that window. I'm going to undock this again. I mentioned this band data, and there's 3 options here. There's minimum, average, and maximum. So let's look at the other 2 options for a minute. And wherever I want to put this window, it wants to dock. I don't want to dock it. All right, so we're going to switch to minimum. And now when we're on minimum, we see that the minimum for this interval should be 001. And we see now that statistics is showing us our first band is at 001. And the next band's at 01, exactly. And so we look for where 01 occurs, and it occurs, 0.010 occurs in this band. The next band is 0.08, and 0.08 occurs in that band between 06 and 0.1. The next band is 1.3, and you'll see it occurs here, and so on for the others. So there's minimum, and then we go to maximum. Our statistical minimum now becomes 0.01 because we're saying the data associated with this lowest band is the maximum of its band. Now I'm showing you this because when you export this data to software like ArcGIS as colored bands with numeric attribute data, you'll want to decide what is the most appropriate assignment of data for each of the bands. And that depends on your preference. Do you want to assign the min, the average, or the maximum? And there's rationale for all 3, which is why we give you the choice for all 3. Okay, I'm going to redock this window. Okay, let's move on. I'm going to close this package windows and overview so I get all this application. By the way, when you close windows, they get closed here, and you can always turn them back on or off right here on the Home tab under Windows. We now sort of understand how to see our data and how it's colored based on whether it's colored on the minimum, the average, or the maximum of the bands. I'm going to switch this back to average, which is the default. And now let's take a look at the colors that we get. So let's go to the contour data module properties, the output ports properties, and we want to edit the nodal data map. Now, you'll notice this is one of the few modules where the node and the cell data maps look the same, but we still are using nodal data for the assignments to these solid colored cells. It's a little bit of ironic, but it's because we use cell data for geology, and so we didn't want to be using cell data for something that's not geologic. Now here is our data map. It's our default data map that goes blue to red with compressed green region. And so the colors that get selected for the min, max, or average come out of where these band breaks or centers occur in this data map. But sometimes you might want to be able to set these 7 colors individually to be whatever you want them to be. And so to do that, we need to do a couple things. The first thing we need to do is copy. And what are we going to copy? We're going to copy the ISO levels, or the level breaks, from the output contour levels here. And we hit OK. And now all of these breaks, the same numbers here are the same numbers that are here. 0.01 to 2236, 0.01 to 2236. And we can tell it further that instead of pulling these colors from a continuum color, that we want solid color breaks. And when we do that, we now have 7 colors, 1, 2, 3, 4, 5, 6, 7, and we can set those 7 colors to be whatever we want. So when we apply this, we're going to see a shift in the colors, a shift in the way this looks. And I want you to pay attention. I'm going to hit apply in 3, 2, 1, and that shift was pretty significant, wasn't it? I mean, where we used to have yellow here, where we now have green. But it's easy for us to go in and change that. So if we want to, let's go in, and we don't click here, we click over here. We click on the green, and this is the first green color, and we want to change that to be yellow. We just go right there and give it a yellow. And I'm going to give it a very slightly greenish yellow. And then we go to the next color, and I'm going to make that a yellowish orange. Stay on the low side of orange. And then I'm going to make this next one a deeper orange. And the last one at the top, a dark red. And now when we apply, again, in 3, 2, 1, we'll see that we have very different colors. Now, there's very little red here. The red is occurring. We can't zoom with this Datamap Editor window open, so we close it with OK. The red is only at the very tip of this highest sample, where we have the hottest sample in our data set. If I click on it, that's our sample that's at 9364, the peak value for all the data. Now again, you can make any color whatever you want. So for example, if you want to change that orange color, let's go back to it a second, and make it white. It'll stand out kind of in a crazy way, but you can see now that's white. So you don't have to follow what was the original continuum colors, although I think it looks pretty strange like that. So I'm going to bring it back to orange. And even though we're here, we're going to hit OK again. When we go back to contour data and we switch to color based on the min or the max versus the average, we see a different distribution because we pull different data. Okay, so hopefully you have a better understanding of how you can edit the colors, again, with the data map. And I want to go back to the Datamap Editor and just do a quick review for you. So we went from a default that had these fixed breaks and 2 breaks that didn't apply to our contour data breaks. And if we hit apply here, we had these colors. So we had red, orange, yellow, a large area of green. And if we copy the ISO levels from the contour levels output port, we get our breaks. And if we turn on solid color breaks, then we get back to having these solid breaks. And these are the ones that have the 2 shades of green, so they're a little more difficult to tell apart. So again, we could go in and change any of these, but I'm not going to do that this time. So that was the process we went through. Now, when you import this as a shapefile in ArcGIS, it won't remember your colors. Shapefiles don't have colors assigned to them. So the colors are going to have to be reassigned as symbology options in ArcGIS and ArcScene. And at that point, you can assign whatever colors you want. You're only going to have 7 unique data values, as we've seen before when we looked at the statistics. And what those values will be will vary depending on whether you choose the min, average, or max option for the bands. I hope that this was useful for you. Again, in contour data, we're using the user define. If we switched over to automatically set contours, we now have a lot more contours and we have an inappropriate data map. Notice that a lot of the contours are the same color because we have a data map with 7 colors in it. So I'm going to switch this to be 1 log per decade. And this is closer to our match, but we have 1, 2, 3, 4, 5, 6, we have 7 colors. So this should work out, but the breaks are going to be at different places. So now that we've set the contours to 1, I'm going to switch this back to average of band. And we can go in and look at the data map. And starting from the default data map, we again would copy the levels and set solid colored breaks. And we can adjust these colors as we see fit. So I'm going to make this green one yellow, that yellow orange, and the orange red, and apply. So now we have our band set correctly. Now the ability to copy data maps, or to copy, you can copy data maps from a module, and you can copy data maps to a module. So let's do one more thing in this application. I'm going to cancel out of here. And we have the post samples module, and you'll notice that the colors of the samples don't match the colors of our solid colored bands right now. So I'm going to go in, I can go into post samples data map or contour data map and copy from one to the other. So I'm going to just stay where I am in contour data, and I'm going to copy from the nodal data map to post samples. And when I do this, hit OK, I'm done. You'll notice now that these colors match much better. And if we look at the data map for post samples, you'll notice that it has the same breaks. So it's going to assign its continuum set of colors for its 100 data points or whatever to the color that wherever they fall and which band they fall into. Okay? So you've learned how to copy data maps from one module to another. You've learned how to assign solid colored breaks to data maps. And you've learned all about the use of the contour data module. Thank you.